Dragonfly is a rotorcraft mission to one of Saturn's moons, Titan. We're really curious in understanding how life evolved on Earth, how we came to be, and we see Titan as sort of a precursor to what it takes for life to form.
Titan has an atmosphere. That's why the rotorcraft is a good option for the Dragonfly program. By doing these hops and flying to these different regions, we can get a broader sense of the makeup of Titan.
It's an octocopter, so it's got 8 propellers, rotors, that power it. The rotors are one of the most important parts of the craft. Without the rotors, it doesn't fly. Then we can't get the information that we need.
Dragonfly is going to be slamming into the upper atmosphere of Titan, and immediately the rotors are going to have to work the first time. There's no room for error here, so any concerns with structural dynamics or aero-rotor performance would need to be known now.
We're machining 8 rotors for the wind tunnel test. All the fixturing had to be custom made. We're removing so much material. We're going from 350 pounds down to 6.5 pounds. We didn't have extra material or the time to make an extra, so everything had to be perfect every time.
Why the blade looks the way it does, that was actually an overlap of where we're very efficient on Titan, where we can find venues on Earth to test it. As a rotor engineer, the wind tunnel testing is one of the most important venues for us to prove out the design.
The Transonic Dynamics Tunnel is the nation's flutter tunnel. We do structural dynamic and flutter testing of aircraft at transonic, supersonic conditions. We can pump the tunnel down to low pressures, but then also fill it with a heavy gas. We can control the density of the test medium and therefore simulate precisely the conditions on Titan.
On this particular test, the focus is primarily aeromechanics. All of the data will be combined to create very high fidelity representations of loads, forces, dynamics. We can use that to predict the performance on Titan with a high degree of confidence.
We're going to be acquiring gigabytes of data that will help determine the structural capabilities of the rotor blades, of the arms, and of the vehicle. You have to understand all of these boundaries in order to ensure a safe flight for that project that's going to take humanity all the way to Titan.
This was a very successful test campaign. Without the ability to get to NASA Langley, we couldn't accomplish this incredibly ambitious mission. Using some of those resources is what's going to get us to the finish line and to Kennedy ready for launch.
It is so kind of out there in terms of a concept. You know, we're going to launch a 2,000-pound vehicle to go fly around another moon. It's just kind of beyond the realm of what most people think about science fiction.
We got a huge crew of very brilliant and intelligent people. There isn't too much that we can't overcome. With us all working together, the sky's the limit.